Thank you for joining us today. In a minute or two, we will be introducing you to the 2010 ISB 6.7 liter engine. I'm Lou Wensler. At Cummins, I manage our on-highway communications. Also joining me is Jeff Weichert. Jeff is Vice President of Mid-Range Engineering. Over the next several minutes, Jeff and I would like to share with you the engine, the features of the engine. We'd like to talk about why Cummins chose selective catalytic reduction, or SCR, as the technology to reduce NOx to meet 2010 emissions. We'd also like to talk about the benefits of the product. We'll share some of our testing experience with you, and then we'll summarize. So Jeff, let's get started. Let me turn it over to you. Where would you like to begin with the engine?
Well, thanks, Lou. It's good to be here. Let's start at the top. This is a coalescing filter. Before I get too far into it, I think I'd just like to point out that it doesn't look a whole lot different than our 2007 product does. So there's not a lot of change you'll see just looking at the engine. But we have our coalescing filter to take care of blow-by gases, our EGR cooler system to cool our EGR gas, electronic VG, variable geometry turbocharger, some enhancements to the turbocharger this year, but primarily we're still looking and using it to drive our airflow, controlling our EGR flow. If you look at this on a CNAL engine, you'll notice the electronic actuator of the turbo is rotated up for our CNAL product.
Okay.
If we follow the EGR valve around to the other side of the engine, you see it comes to the EGR valve. This valve is the same valve for both the ISC, the ISL, and the ISB engine. It's the same part. We have the ECM 2250 control module here. This module is actually the same for all on-highway products, both heavy-duty and our mid-range products. On the B, we're using a high-pressure Bosch common rail fuel system. It's the same fuel system we had in 2007. For the C and the L, it's using the XPI common rail fuel system, the same system that was used in 2007. And having XPI part of Cummins fuel systems just points out the integration we're able to do having the various components and technologies in-house. So we have the fuel system, we're using the Cummins fuel system on the C and the L. I just went through the VG turbo on the other side. That's from our CTT group. Of course, Cummins filtration. And on the back side of the engine, of course, our after treatment is connected, and that's part of our CES.
Cummins emission solution.
Right.
So after treatment is part of the solution for 2010. Would you come back and explain a little bit, why did we choose selective catalytic reduction as the technology for NOx control?
Right. Well, selective catalytic reduction, SCR, was really chosen for mid-range because it was the only technology that met our customer requirements in the marketplace of hitting the power density for our high-end markets and delivering fuel economy for our medium-duty truck markets. The SCR system is effective at reducing NOx and delivering those customer requirements.
I know that early on for your engineering teams, you folks did evaluate an in-cylinder solution, or what others would call an EGR-only solution. So what are things that we learned early on from that really helped reinforce that we chose SCR?
Well, an EGR-only solution to get NOx levels down to 2010 levels is very difficult, and it takes a lot of EGR. Not impossible, but it takes away a lot of the deliverables that our customers are expecting. I can't get to the power densities that we're expected to deliver to our customers in various markets. You have to move a lot of EGR gas into the cylinder in order to achieve these low NOx. Not only do you have to move a lot of the exhaust gas, but you have to cool it, because you need to get the volume down and the density up so you can actually get it in the cylinder fast enough to actually impact and get the reduction in NOx that you get out of cylinder. Moving all that EGR gas and cooling it creates its own problems. You get condensation. Even with ultra-low sulfur diesel, we still get condensation of sulfuric acids. So then you need bypass systems to control your condensation and when you're going to flow it. Because you're moving so much EGR, you need to push it quick. It affects how fast you can accelerate and your throttle responses. So it just didn't meet all the requirements we needed to in order to hit what our customers expected our products to do.
Let's come back to the after treatment system and give us a refresher for what the after treatment is, and then explain a little bit about how SCR works.
Sure. As you recall, in 2007 we introduced a diesel particulate filter onto the product, and the diesel particulate filter included a DOC catalyst, an oxidation catalyst, and then the particulate filter behind it. That system works just like it did in 2007. In addition, for 2010 we put what we call a reactor pipe and then an SCR catalyst behind that. In the reactor pipe is where the dosing injector for the diesel exhaust fluid is introduced to the system. In that reactor pipe is where it changes state from liquid to ammonia gas and reacts inside the SCR catalyst to reduce the NOx. And then of course it goes out the tailpipe from there, Lou.
Okay. Now you mentioned diesel exhaust fluid, so here's something new. It's the reactant that we have to use in order for the SCR catalyst to function properly. And I know there's been a lot of talk in the marketplace. I think a lot of customers have questions about the fluid, the properties, and would you reflect on our testing experience both in cold climate and in hot climate operation relative to diesel exhaust fluid?
Sure. I think that all of us were worried when we first started, but we've done a lot of testing. In fact, during 2010 development, we wanted to have several seasons where we could go up to the Arctic Circle and get to temperatures below -40 Fahrenheit, and we also took it to Death Valley where we could see extremely hot temperatures. In the cold temperatures below -40, we've built in systems into the whole SCR system where we heat the tank, we heat the lines, and we thaw the fluid. It freezes. There's no mystery there. It does freeze. But you know, the systems are developed to thaw the fluid and beginning injection. On the hot side, when we're in Death Valley, we're in temperatures at 120 degrees Fahrenheit or better, and we also use that opportunity to run up and down the mountains and test at altitude at the same time. A lot of articles have been written about deterioration of the fluid in the hot temperatures, but to be quite honest, we don't see it. We don't see it in the performance of the engine or the performance of the SCR system.
Okay. So just building on testing, would you expand our approach at Cummins in engineering, how we go about testing, evaluating, improving our products, please?
Sure. I don't think that it's a surprise that our products have actually increased in complexity, and as such we have developed our testing around supporting that complexity. So we're actually running our field tests in a variety of different duty cycles and applications. So our ISL in transit buses, our ISC in the vocational markets, the ISB and the C in our medium duty truck markets, and we combine all of those field tests to really learn how the engine and systems are going to behave in the different duty cycles we sell into. But prior to actually going to the field, we've developed what we call system level tests, where we go through this in the test cell before we go out to the field and really look for the system behavior. And we have developed these test cycles around the field duty cycles. So one of our system level tests actually mimics a transit bus. Others will mimic a pickup and delivery cycle.
Okay, okay. So let me ask you to sort of summarize. You know, I know that you've been through now these 3 emission cycles. I'm thinking of 02 and then 07 and now 2010. So as you reflect on our 2010 mid-range products, what would you like customers to know from your perspective from engineering?
Well, from engineering, our goal is always to make the next one better than the last one. And we've worked pretty hard to deliver with our 2010 products fuel economy, better reliability, ease of installation, better performance, and improve our power density of the products. And I would challenge you to put this in your vehicle and drive it, because I think you'd be pleased with its performance.
Jeff, thank you for being with me today.
You're very welcome, Lou.
So So the message that we would like to leave with you today is simply this, that for 2010, our products will deliver better performance, better fuel economy, and better reliability every mile that you'll drive them. At Cummins, we are ready for 2010. Thank you for listening.